projectile motion. Have you ever wondered why a ball wouldn't just fly off into different direction when it is thrown into the air? Or why form some arc when it falls into the ground? A projectile motion is an object shot in the air and the path of projectile that the gravity causes to move downward is called trajectory. For example, a ball is kicked by a football player into the air. The ball would be our projectile, and the moments across the air that form a parabolic path caused by the gravity pull would be its trajectory. The projectile motion finds application in sports, playing basketball, football, golf, tennis, as examples of projectile motion in real life. While throwing a basketball into the basket, the player shoots the ball in such a way that the flight taken by the ball is the form of a parabola. Other examples are shot put, javelin throw, and baseball. History of projectile motion. Galileo was the first person who ever accurately described projectile motion. He was the one who first broke down motion into its separate horizontal and vertical components. Utilizing these revolutionary insights, he then concluded that the curve of any projectile is a parabola. How was projectile motion discovered? In one such experiment, an early one dating from about 1605, Galileo used a groove plate inclined at a small angle to the horizontal. A metal sphere was released from a point on the inclined plane elevated some distance above ground level and allowed to roll off the end and complete a free trajectory. Galileo's famous experiment. Galileo's projectile model. Through these experiments, Galileo established that the motion of a projectile is a combination of constant horizontal velocity and vertical motion in which the projectile accelerates at a rate of 9.8 meters per second squared.
Factors affecting the flight path of a projectile are gravity, air resistance, speed of release, angle of release, height of release, and speed. Gravity. What is the effect of gravity on a projectile? It increases the height of projectile can attain. Air resistance. There are several key factors that bring air resistance into play. The larger the surface area, the more air resistance will affect the object. Example, basketball compared to a golf. The type of a surface, the object, if the surface rough than air, the resistance will be greater. Speed, as speed increases, so does the resistance. Space shuttle. The smaller the mass, the more the air resistance will affect it. Speed of release. The reverse of the fast object is release, thrown or hit. A projectile speed of release is largely determined by the muscle force. Generally, the greater the speed of the release, the greater the distance gained. Angle of the release. This refers to the angle of the object is thrown at or hit into the air. What would happen to the angle of the release were too high for a given activity? Poor distance gain. What would happen if the angle release will too low to the given activity? Poor flight time and possibly poor distance. Height of release. Increasing the height of release improves the horizontal distance objects can be projected. For given speed and the angle of release, the greater the height of the release, the greater the distance gained. This because the time in the air will be greater. When applying force a projectile below above the size of the COGU will impart spin into the projectile. This helps the projectile to maintain its course and can cause it to a change height or direction. There are four main types of speed can be imparted to projectile. Top speed. This is where you hit over the ball. Top speed creates downward forces. into a ball, causing the ball to drop. 2. Backspin. This is where you hit under and slice the ball. Backspin creates an upward force that lifts the ball, causes the ball to rise. Clockwise spin. This is where you hit the ball on the left side and the COG. It causes the ball swing to the right. Anti-clockwise spin. This is where you hit the ball on the right side of the COG. It causes the ball to swing to the left.
Components of projectile motion. First, we have horizontal motion. The horizontal motion of a projectile is constant, assuming that there is no friction acting on the object. It is originally accelerated horizontally. However, once it leaves the hand, it has no force acting upon it from this direction. No friction means that there is no force in the opposing direction. Gravity has no effect on the horizontal velocity as it works perpendicularly to it. As a result, the net force on the projectile is zero, resulting in the projectile continuing to move with the same horizontal motion. Next, we have vertical motion. The vertical motion of a projectile is non-constant, as it is thrown upwards originally with an unbalanced force at an angle. But once it has left the thrower's hand, it no longer has a vertical force working on it, save for the possibility of some friction from air resistance, which we are ignoring. However, it has the force of gravity working on it, pulling it back down towards the earth. Thus, the projectile will have a vertical velocity which decelerates until it reaches its maximum point, in which case it begins to accelerate its velocity, but this time in the opposite direction, downwards. So here is the diagram for horizontal motion, and as you can see, the cannonball was launched horizontally, and as you can see, the horizontal velocity is constant at 20 meters per second going to the right, and the vertical velocity starts to go up because of the gravitational force of 9.8 meters per second squared. It's negative because it's going downwards. Here is an example of the vertical motion. As you can see, the vertical velocity started at a positive number. That is because it was launched upwards, and it continues to decelerate until it reaches the maximum point. And then as it goes down, the velocity starts to go in the negatives because it's going downwards.
Let's solve some problems. Problem number 1. A brick is thrown upward from the top of a building at an angle of 25 degrees above the horizontal and with an initial speed of 15 meters per second. If the brick is in the air for 3 seconds, how high is the building? Draw a picture. Here is our example of free body diagram. So as you see on the example, Vi is equals to 15 meters per second and delta T is equals to 3 seconds. These are all given and you will see it on the problem. Then we will find the initial and vertical velocity. Sine 25 degrees equals to Vy over 15 meters per second. Vy is equals to 6.3. Now use the y component information to find the height. Then we will derive with this formula and we will simplify it. Then we will get the answer of y is equals to 26 meters. Therefore, the height of the building is 26 meters. Problem number 2. A daredevil tries to jump to the canyon with a wind of 10 meters. To do so, he drives his motorcycle up inclined slope at angle of 15 degrees. What is the minimum speed necessary to clear the canyon? Here is the picture. Solving this problem requires working with two equations and two unknowns. First, write the constant velocity equation from the horizontal direction, and it is given below, where v represent the total velocity at 15-degree angle. Solving for v, so here is the equation 1. Now write the constant acceleration equation for the vertical direction, and we will came up for our equation number 2. Feel free to pause the video. Now combine equation 1 and 2 by substituting for v, and we will get this equation. Simplify the given equation, then solve for dt, and delta t will be get. Substitute the values, and we will get delta t of 0.73 seconds. Now insert the time equation to find v, and 14.18 meter per second is the minimum speed needed for success.